All right, this is 7.2, types of reactions. So we've got about 5 different types of reactions that we're going to go over today. And they're all pretty easy to determine the type of reaction they are just by kind of looking at them. But eventually what we'll have to do is we'll actually have to predict the products that are produced when two specific reactants are combined. And that's the more difficult part. Today, though, let's just focus on identifying the types of reactions. So we'll start with small ones first. Let's start with the synthesis reaction. A synthesis. If you think of the word synthesis, it means like combining things. It means bringing things together. So let's look at the combination of magnesium metal and oxygen gas. And you need a little bit of heat in order to make this reaction actually occur. I'm going to put the phases in here. If it's a metal, it's a solid. If it's a gas, it's a gas. Yeah, right. Okay, so if you get these two things together and you like squish them, you're going to produce a new material. It's a white powdery material, and it's called magnesium oxide. So it looks like this, MgO. There you go. And it's a solid stuff. It's a powder. It's a solid. So put an S after there. So this is a synthesis reaction. We got to balance it, right? So we need a 2 out in front. We need a 2 out in front. So the way that you kind of investigate and determine a synthesis reaction is you've got a bunch of stuff on the reactant side, the left side, right over here, right? And then you have less stuff, you have less plus signs on the right side. So you're taking two, making one, bringing them together. That is essentially a synthesis reaction. All right, let's do the opposite of that then. We call the opposite of that a decomposition reaction. Okay, a decomposition reaction would be taking one thing and essentially breaking that one thing apart. Okay, that's a decomposition reaction. Let's see, I got to think of one off the top of my head here. Oh, okay, I got one. Let's take water, for example. Okay, let's take some liquid water. And we have seen the electrolysis process in class. And that's just taking liquid water and it's busting it apart into its constituent elements. All right, so we know that it contains hydrogen, so we break it off into hydrogen. Got to remember, hydrogen is one of those diatomic, right, dependency issues, and it has it's made of gas, and oxygen is the other thing, and that's a gas. Okay, so you see that the synthesis and the decomp reactions are kind of the opposites of each other. Look at where the plus signs are, right? One's on the left, one's on the right. Okay, that's how you determine whether it's synthesis or decomp. All right, again, let's balance this because balancing is important. There we go. All right, notice phases are there, balancing is there, yield sign is there. All the big important things that we need are present. All right, let's go to a third type of reaction then. This type of reaction is going to be called a combustion reaction. Combustion reaction. So if you think of the word combustion, what do you think of? I think of exploding things and pyrotechnics and awesomeness, and that is a combustion reaction. So we shall investigate the reaction that occurs every time that you turn on your Bunsen burner. Methane gas is the stuff that comes out of your little spigot there, and it's combined with some other things. One thing's called mercaptan, and that's what makes it smell like rotten eggs, and some other things in there. But mostly it's methane gas, and it's very combustible. Okay, so a combustion reaction is a reaction defined as you're taking some substance, you're combining it with oxygen, and it's producing heat. That's essentially a combustion reaction. And we're going to look at very specific types of combustion reactions here in this chemistry class. They're going to be called hydrocarbon combustion reactions. So let's break that word down. Hydrocarbon. That is something that has a hydrogen and carbon. So that would be a good example, right, of a hydrocarbon. Yes, it would. Super example. All right, so when these two things combine, methane, oxygen, we get two products for the most part. All the time. And the same two products all the time. When hydrocarbons and oxygen mix are the following. They are CO2, gas, and H2O, gas. All the time, all the time, all the time. Now, there's trace amounts of other things that are produced, like carbon monoxide, which is bad stuff. And this is why you should never burn a Bunsen burner in an enclosed room without ventilation, because there'd be a little bit of carbon monoxide that's produced, and that's bad stuff, and it could cause serious harm. So try to avoid that. All right, so this is a combustion reaction. Again, we should have all of our phases in line. There we go, lots of gases. And then, actually there's heat produced. And we'll get to the whole heat thing later on in this chapter. You don't have to put it into your reaction right now, but it's produced, so it's on the right side. Okay, balance this, right? There you go, and there you go. Now we have a balanced chemical reaction. So that's a combustion reaction. All right, so we have 3 types of reactions to start out with. Synthesis, yeah, decomp, woohoo, and combustion reaction. And you need to know that carbon dioxide and water are produced in a combustion reaction. Okay, now let's move on to the last 2 types of reactions, shall we? Of course we shall. Let's see. Let's make this next one purple. Okay, the next one is called a single replacement reaction. We call this the Homewrecker reaction, and then you'll see why in just 1 second. Single replacement reactions you have seen in class, and in fact, you did a lab. Hopefully you completed the lab on Thursday, and hopefully you got super stupendous numbers of a single replacement reaction, and it looked like this. You took some iron, and you combined it with a solution. And this was solid, right? This is solid. A solution of copper chloride, CuCl2. Okay, solution. So what is this, right? Aqueous. Yeah, there we go. All right, and you produced some stuff. I'm going to kind of give you a little hint at what you produced. Oop, see that too right there? Very important, very important. And that was in solution. That was actually aqueous stuff. That was the icky yellowish solution liquid that you poured off and dumped down the drain, and you asked me like a million times, can this go down the drain? And I was like, yeah, unless it has HCl, and then you have to pour it in the ice cream bucket. But that was that stuff. And then the other stuff, the stuff that you put in the beaker and you weighed, and it was kind of pretty, and I always kind of want to collect it because it's really cool, is copper. And that was solid. All right. So again, balance. Hey, it's balanced. All right, super. So this is balanced chemical reaction. This is a single replacement reaction. So why do I call it the Homewrecker reaction? Well, check it out. So essentially, copper and chlorine, they're happy, they're hanging out together. And then all of a sudden, this iron dude comes in and he's like, hey, copper, you need to go find something else to do. And then iron pairs up with chlorine. It's like, oh, they match up then, and then they hang out. And then copper is sad because copper is all by him or herself. And then that's bad. So this is, the Homewrecker reaction. There we go. So that's a single replacement reaction. Now, the tough part here is predicting what's going to form. So eventually, I'm not going to give you the stuff on the right side of the reaction. I am going to tell you, hey, you just tell me what should form over here. And I'll just give you this stuff, and you'll have to tell me, ooh, that's tough. But you'll do it because you're all very bright humans. All right, so last type of reaction then is called, if we got a single replacement, I bet you we have a double replacement. You're going to say, oh, I bet you we have a triple replacement. No, we don't have a triple replacement. So we just have a double replacement reaction. All right, so let's see. Let's find out a double replacement reaction. Now, I call it, the single replacement is the Homewrecker reaction. Double replacement is the swing dancing reaction, or the line dancing reaction. We'll see why in just a second. All right, let's say we've got some magnesium fluoride, some cool stuff, and let's say that's in solution. Okay, and then we add that to, I'm going to make this a different color because it's kind of neat to see colors. We add that to, let's say, I don't know, calcium iodide. All right, super. It's that stuff right there. And that's aqueous too. Okay, and then I'm going to have a yield zero here. That is not a pretty color. It is just white. Okay, so like in line dancing, what happens is every once in a while you're swinging around and you're swinging around and you switch partners. Okay, you go to the other partner, and then you dance with that other partner for a while. That's what happens here with this particular process. Actually, guys, I hate to do this to you, but I am going to change this. I'm going to change this to this. Yeah, there we go. Okay, so calcium oxide. There we go. So we get this switching of partners. Yeah, all right, this do-si-do effect. Okay, so what happens then is you now have magnesium that switches. And what is magnesium going to switch with? Do you think magnesium will go with the calcium or the oxygen? Well, calcium's a metal. It's a positive ion. Magnesium's a metal. It's a positive ion. Do positive ions like to come next to each other? No, they certainly don't. So really, magnesium has no other option than to pair up with oxygen. There it is. Okay. Now, calcium doesn't like to be alone. So it is going to also pair up, but it is going to pair up, I need my right color here. It is going to pair up with the fluorine, right? So we've got calcium, and it will then pair up with the fluorine. There we go. Awesome. Now, here's something interesting. one of these two things, either the magnesium oxide or the calcium fluoride, is going to form what we call a precipitate. And we abbreviate that PPT. That's a precipitate. No, it is not snow or rain or what you're thinking about precipitation. It is a solid. I'm going to show you this in class on Monday. It's really kind of pretty and kind of cool. And you'll see like a solid form out of two liquids. Oh my goodness, magic. Not really, just chemistry. So let's say for kidding's sake, it is this guy. So whatever forms the precipitate, we call that a solid. We put an S there. The other thing then remains aqueous. There you go. So this, guys, is a double replacement reaction. Probably the hardest types of reactions to identify and to write. And we will practice a million times in order to make sure that we understand how this works. All right, I hope you all have a good break, and please be careful of that crazy 200-pound egg-laying bunny that jumps around this time of year.